So, by the way, this is my first time I can meet Burak and thank him for all the contributions. Without him, by the way, I couldn't be here because, it's him and some other folks at Databricks who, created Spark, starting with Matej, Reynold, Michael, and others. And by the way, Michael had a great impact on what I'm going to show today because he was the man behind this code. The very first code drop was from him. I think he was an intern at Google when he was doing it. And that's where Catalyst and all the optimizations you may have experienced in Spark started. Okay, so I'm Jacek Laskowski, and because the room is pretty large, I'm gonna be here. So I apologize for being a little bit higher than you guys. Don't feel, how to say, sucked or humbled. No, I'm here just to see all you guys, okay? And by the way, I want to have this talk very interactive, so please ask your questions so whenever you feel you miss something, okay? I gave this talk 1 week ago in Warsaw at Spark Meetup, and it took me 1 hour and a half. And I added a few slides, so yeah, we might be a little bit at fast pace here. Okay, so internals of structured query execution. So that's a pretty nice talk and speaker. Hope you like it. So this is about Apache Spark 2.3.1, and the reason I'm highlighting it is that there is one slide that's only available since Spark 2.3.0, even though the since marker is 2.2.0, it's only available in 2.3.0. So please keep in mind that most of the information here are available since Spark 2.0, but there are some information that are only available since 2.3, okay? Good. And it's about Spark SQL, even though we will have a glimpse at RDD API just to compare why we are here and listening about Spark SQL, while Spark was famous when Spark SQL didn't exist. RDD API was pretty good at the time, and now we've got Spark SQL. So you may be asking yourself, why Spark SQL while Spark core RDD API was kind of good? So I'm here to give you some answers. Okay, so I'm independent consultant. I'm focusing exclusively on Spark with some exposure to technologies that are commonly used with Spark, like Kafka, DCOS, Mesos, and others. Quite recently, I looked at Kafka streams and got a big shout out from Gwen. Thank you, Gwen. She's not here, I can see. So I'm contributing. Contact me at Twitter or Stack Overflow, or if you need, use this old-fashioned way, emails, okay? So Jacek at Japila.pl is how you can reach out to me. I'm best known by these Gitbooks, but I'll skip it, and Stack Overflow. Okay. As you can see, agenda is fairly packed with information about Spark SQL. Again, if you feel you know it, you can leave anytime. I don't feel, wrong about it. Okay, so structured queries. There were lots of talks about why structure is important. We are talking about structured queries because we want to know something about our data. And the data, the shape of the data, the schema of the data is important because we are talking about in-memory computation. So the more we know about the data we are going to process, the more we can pack it into RAM and be as fast as possible without touching disk. Okay, that's what Spark uses, and that's what Spark SQL uses to generate the code that uses RDD API under the covers. Okay, so structure is a query. It's just a query. I apologize for my pronunciation. I think it's query, not query, or whatever. And schema is just a tuple of 3 elements. I'm going to be as technical as possible, so I apologize for lack of university background about databases. I learned about databases from studying the source code of Spark. That's the only knowledge about databases and the theory behind it. So thank you, Burak, thank you others for teaching me Spark and databases. So schema is just a tuple of 3 elements in Spark SQL. It's just a name, it's just a type, and whether it can be null or not. Okay? These 3 information says everything Spark SQL needs to prepare before processing your data. Okay? And by the way, we are back to SQL. So we are again embracing SQL. And perhaps because of my age, I only now notice how elegant and nice SQL is. I remember days 10 years ago when I said SQL is for people who should go away, long ago. But now I can see that it's very expressive. It's a high-level language, and I like that Spark SQL embrace SQL to the point that the API, Scala API, Dataset API for Scala, is almost like SQL. I learned so much about SQL by studying this API. Especially windowed aggregations or similar things. So yeah, that's pretty cool. So these are 2 examples of structured queries. You may like SQL way, or you may like Dataset API. I'm a Scala developer, so I'm using Scala. Despite my title as a Java champion, I'm now championing Scala, Spark, and JVM. Yeah, Scala. And this is, join. And by the way, Don, thank you for code reviewing or slide reviewing my slides before my talk, because he said that these 2 queries were not matching themselves. Now they do, because now I'm joining using Dataset API and this SQL, right? Right. And I check it. Spark SQL accepted these 2 queries, okay? So I'm fine, okay? Even though they might not look nice to you, to your SQL eyes, they are fine. Okay, so why is structure important? Because we are processing big data. And I am not here to explain what big data is. I'm relying on your intuition. And whenever you think about 10 computers that are needed to process your data, this is big data. If it's not enough, just multiply it by 2 or by 10, and you will get 100 machines. And you will need, something that will cope with the number of machines available. This is Spark, Spark Core. Spark Core and RDD API are about distributed processing. That's it. It's only now when I see this, the meaning of this general purpose distributed computation platform. That's Spark, okay? Spark SQL is nothing else like a module that uses SQL and SQL-like API to express distributed computation. Okay, that's it, or distributed computations. Okay, good. So we've got query languages in Spark SQL, and you can divide them by programming languages like Scala, Java, Python, or R. I heard about F# and C# supported by this Microsoft open source project. Can't remember the name now, but anyway, there are and because of this architecture I'm gonna show you, it's easy to enable other languages to play nicely with Spark. Because after all, Spark SQL is nothing else like a function that generates code for using RDD API. That's my understanding, and please correct me if I'm wrong. And we've got high-level declarative languages like SQL or untyped row-based DataFrame, which is nothing else like dataset with correct encoder, typed dataset. It's more it's better to understand the difference between DataFrame and dataset if you with languages that support types. I'm not speaking about semi-types in Python that you can create classes. I'm speaking about languages like Java or Scala, where you can say, okay, this is generic type, so it's a type constructor that can construct new types. And DataFrame is an instance of this type constructor called dataset, okay? Good. So SQL, I'm going to skip it. And by the way, one information that I will not skip is that this Eller grammar was borrowed from Presto. It's a database from Facebook, if I'm not mistaken, written by one of the people I always followed and watched, Dane Sandstorm. I apologize, Dane, for not pronouncing your name properly. I was with him when we were developing, or he was developing Geronimo. Back then, when Geronimo Java EE application container was kind of fine. So he created Presto, or he was part of this Presto project, and he contributed it. And if I'm not mistaken, my understanding is that the grammar, Eller grammar, was borrowed from Presto with some influence from databases like Hive. This is space for HiveQL, Postgres SQL, and Oracle and Microsoft. And you know why? Why did these databases influence the grammar? Why did Spark embrace other databases? Why was this important? Because Spark devs or Spark projects want you to use Spark whatever you are using right now. So if you are migrating from Hive, fine. If you are migrating from JDBC-based databases, relational databases, fine. You can easily migrate from your existing architectures into Spark, okay? Embrace Spark. This is what they say through this Eller grammar. Yep. Okay. Okay, so we've got data frames and schema. So when we work with data frame, we don't care much about types. It's pretty loosely typed. You can just reference a column and say, okay, just compare it to one. Scala compiler, since I'm a Scala developer, can't help much. It cannot prove at compile time, before you deploy your application to production, that this query is correct. That's why we have a more type-safe API called Dataset, and that's why they switch. When I say they, I mean Spark devs. They switch from DataFrame only API into Dataset with encoders. So DataFrame is just type alias in Scala. If you are a Scala developer, you know it's just a synonym for something else. So this is a synonym for Dataset with row encoder. Okay, so and now we are talking about data sets, and they are important for you guys if you are more into programming rather than declaratively expressing your thoughts, how to process your queries, how to process your data using SQL. So here, data sets are the bread and butter of any Spark SQL developer. Embrace it or not, or like it or not, you will be working with data sets quite heavily, quite often, whenever you are with Spark SQL, regardless of the query language. Eventually, everything is turned into data frame, and you will see it in a moment why. Okay, so know it. SQL or Java or Scala, DataFrame API for whatever language, eventually turn into dataset. Okay, we've got this encoder. An encoder is kind of similar to what you may have seen with Kafka, where you had to define your serializer, or perhaps in databases like HBase. I haven't worked with this. I just heard that there is this byte serialization, deserialization. So encoder is just a function or class instance of a type that's responsible for encoding your data from JVM object into internal representation, internal row. Okay, and why is it important, you may ask? It's because we want to leave JVM as quickly as possible. Why? We hate when we have GC kicks in and starts processing or starts cleaning your plates or your memory. So we wanna skip this phase of loading all the data onto JVM only to just give you a nice API. So they created this concept of encoders to encode your data, your JVM object, into something they can handle better. And they handle it, Spark devs, they handle it with SunMISC unsafe. So it is unsafe to use this unsafe API, but Oracle promised not to remove it anytime soon. So we are fine. We can invest in Spark more. Okay, so expression encoder is the only known implementation of this encoder API. And by the way, there are places in Spark SQL code where they check it explicitly by saying, now I'm casting this encoder into expression encoder, and they are using it internally pretty heavily. So if you start, writing your own custom serialization and deserialization encoder, you would have to replace some codes in other places too. Okay, so Project Catalyst. I remember my days when I was wondering why people from Databricks, why Databricksians, do they call them like this? So why Databricks says that there is this Catalyst optimizer? Well, Catalyst is just a framework, as you will see in a moment. So I'm here to tell you the truth, okay? So they didn't yet. So Project Catalyst is just a tree manipulation framework. And that's the gist of everything in Spark SQL, or pretty much, okay? 80% of these goodies that you can find in Spark SQL is because of the simplicity of this underlying API, and this is Project Catalyst, okay? Tree manipulation framework. If you've ever studied any computer science book about algorithms, you may have found, or you surely found chapters about trees and whether they are fine. They are recursive data structures, and once you know how to work with a node, you know how to work with entire nodes or nodes with children that are again nodes. Okay? It just, you recursively apply same function to every node from top to bottom, or bottom up, okay? And there is this Project Catalyst API that gives you this transform up or down, where you can pre-process your trees. And what are trees? Why am I so concerned with trees? Because all our queries are trees, right? Right. So once you know it, once you see it, I remember clearly the moment where I said, oh man, it's that simple. When I figured out they are so brilliant, these brilliant minds worked to offer us this nice looking API. So again, thanks Michael and others and the team. So they created tree node, and by the way, this tree node data abstraction is pretty nice from Scala development, Scala perspective. This type looks like this. I know you can barely see it, but look at this. It's abstract class, which is fine. I'm pretty sure that Java developers, Java devs, and Scala devs can easily understand it. But then, look at this base type with this smile between base type and tree node. And again, how can it be that tree node can use something that's tree node again? So can we have tree node, the very first tree node? Yes, we can. And you know what? I cannot explain it clearly. So this is what I considered advanced Scala. And whenever I teach Scala, just to teach others Spark, I say, well, you can study it. It's fine, but it won't give you an edge with any benefit working with Spark, okay? Unless you want to make it even better, even cooler. Okay, but for Spark development, no, not at all. And it extends product. Product is a special Scala type. And look at this, self base type. Oh man. So yeah, what a nice class definition, isn't it? So it's again recursive data structure. It's just one data structure that says everything about our queries. It says whenever you type something in Spark SQL, whenever you write something in Spark SQL, you will get this little tree node, perhaps with some other children, with other tree nodes. That's it. Okay, so what are the tree nodes? Your very first question is, okay, I know what tree node is. Now let's get closer to Spark SQL. So we go up to see the developer API we are using to develop Spark SQL applications. So we've got this tree node, and tree node is query plan or expression. I remember it was months ago, 2 or 3 months ago, when I realized tree node is not a single tree. It's a tree of trees. What's the name of tree of trees? Forest. Yeah, it's a forest, kind of like. Because you can, and you will see rules, which I'm gonna explain in a moment, which will process, query plan, looking at all the operators, but also at expressions. Some rules are not interested in expressions. I'm going to explain it in a moment, but some are. And so depending on what you want to do in your rule, but don't get too crazy with your rules, which I'm going to explain in a moment, because you may overwhelm future readers. So we got tree node, which is query plan and expression. And you know what? When I say query plan, if you ever worked with databases, you know what I'm talking about, right? Query plan is just something you surely worked with when fine-tuning your queries with relational or non-relational databases. They've got this concept too. So now we are closer to this relational or relational-like world. So we've got this query plan and expression. Okay, so what are the query plans? Query plans are logical plan and Spark plan. There are 3 logical plans you will be working with in Spark SQL. There are more. There are 4, and 2 Spark plans. Spark plans are executable plans, something that you will eventually execute. Not you literally, directly, but through Spark SQL, you will go through something I call query execution pipeline, which will pre-process your query to the point that you will end up with Java code. Can you imagine? You are using whatever language you feel comfortable with, like R, Python, Java, or Scala, or C#, F#, whatever. But eventually, Spark will execute your code as a Java code. Why? Why is it important? Why Java? We know that Java is not that cool like Python, which ranked 3 in TIOBE last week. So it's not Python, it's not Scala, other languages. It's Java, because they decided to embrace 2 concepts. It's this tornado concept of iterative processing with code generation from another paper. So they took 2 papers together and they wrote code that creates Java code without any virtual calls, which makes your query even faster without you noticing it, okay? Unless you notice that Spark 2 is faster than what was available previously, okay? So they are generating Java code just to avoid any virtual calls and making sure that the code is as fast as possible. And you know what? There are projects that are to take this concept and generate, rather than Java code, generate native code written in Rust. Matej mentioned something once. I haven't seen it live, but he did. There are also projects with C and other languages. So you can get faster with Spark SQL if you go as low as to see this bytecode level, okay? So I'm pretty sure that you've seen it before. It's just a query plan, executable query plan, optimized Spark plan. This is something that will get executed. It's just simple broadcast hash join. Yep. So we've got whole stage code gen with 2 stages or four stages and in total, and 2 whole stage code gens gave you separate classes for your code. So you generated, or you ask Spark SQL to make this query fast, and Spark generated code for you. Very good. And this is another view on the same concept. It's, again, physical plan. So it's optimized physical plan. This is something you will see. And something you will see often, this number with star in round brackets. Can you see it? Don't get confused with RDD lineage. Remember the days where you look at RDD lineage just to see how many tasks, how many partitions you have. Some people are doing like this, hoping they are not trying to sleep. So yes, you are correct. This is just to say how many code gen stages we had to generate code for our query, okay? So this is completely different from the number of partitions, the number of tasks you will eventually have or use to execute your query. And the star, what is star? What is star before this round brackets? This is just to say that this query went through physical optimization called collapsed stages or something with collapse. This is whole stage code gen, okay? This is to say, hey, for these trees, I mean Spark SQL generated code, Java code. You wanna see it? Yeah, everybody says, yeah, show me. Why? What do you expect? It's just, pretty nicely written Java code. Okay, I'm gonna show you later. So, catalyst expressions. There are expressions, there are query plans, and there are expressions. They are all 3 nodes. And expressions is just a node, executable node in this tree of your query that has this one little it's a single abstract method interface, so to speak, with this eval method that accepts internal row. Okay, and from this internal row, you will generate JVM object. Okay, any. Okay. Now let's go back to Catalyst and talk about rules. We are 20 minutes past or half an hour? 20 minutes? Yeah, half an hour. Oh. So we've got rules, okay? And we are writing rules to process our queries. Why? Because we need to make sure that our queries are correct, valid, it's analysis phase, then make our queries faster at logical stage or phase, so not to confuse with stages in Spark Core. So phase, then we need to plan this. This is another rule, and another rule is to optimize executable query, okay, or query plan. So we've got, as you may have heard, 4 stages out of 6 that are available that we will be working while fine-tuning our queries. And this all boils down to executing set of rules. They are combined together into batches. So batches of rules are executed at every stage to make your code or your queries faster. Okay, so this is just very basic rule. You may have written yourself, like remove all hints. There is one hint supported out of the box, broadcast hash join. This is for broadcasting one side of the join. No other hints are supported. They are simply removed. I think Databricks figured out they need hints for the Databricks cloud product, so they introduced this concept of hints. So there is hint framework that you can use to write your own hints for your own queries. Okay, it's pretty simple. And so when I saw them, this hint framework with this remove all hints, I said, oh, how can I use it? And now I'm in this thinking mode, what I can do with this knowledge I got from the Spark devs. Okay, and the rule executor is just an engine to execute rules. Okay, you can imagine having lots of rules. Someone has to take care of ordering loops. Loops are supported too, and applying it to logical plans at proper stage or proper phase. Okay, now we are at this query execution. Query execution is an object. It's a class in Scala code for Spark, which is just a container for all the phases that use rules and pre-process your trees. So this is what I called heart of any structured query. Understanding query execution is to understand how to make your queries, your Spark applications faster. So there's this concept of structured query execution pipeline with execution phases, not to say stages. So you use dataset explain operator to see what are the different stages, or what are the results of different stages of this query execution. You can access this query execution through this developer API called QueryExecution. It's available, so you can just play around and explore. And also, the last but not least, there is this 2RDD phase that generates RDD or RDD API-based code for you to leverage RDD API of Spark Core. Okay, so this is back to roots where we are leaving Spark SQL and we are entering Spark Core space. You can just say, hey, give me RDD for a given structured query, and now I think I can do better than this, okay, and do some extra maps or whatever. Okay, it's just yet another RDD that was generated from your query execution. And this is a query execution pipeline, or something I call pipeline. I've never seen it used anywhere else, in any other places. So, starting with SQL and dataset, these are developer APIs. So people who are writing Spark SQL application, should we do a break? Because I see people leaving, so, okay. So 1 minute,
Yeah.
1 minute, and then 5 minutes. Yeah, sure. Okay, so I finish it. And by the way, I'm gonna use this slide again in a few minutes again. Yeah, again. So SQL and dataset. So we've got this SQL dataset. These are APIs to express your queries over your data. It has nothing to do with the size of the data. Any query will go through these stages, or through this pipeline. So we've got unresolved logical plan. This is what you may have written by yourself using logical operators. But why would you waste your time if you can use SQL or dataset? These are facades to make your life easier. Then from this unresolved logical plan, we have this Spark analyzer that pre-processes your plan and makes it analyzed. And they say that after analyzer, you will get some result from your query, okay, of executing your query. So analyzer makes sure that your query is valid and passes checks, okay, validation checks. Then we've got this with cached plan. It's another stage, another phase you won't see in explain, which uses your cached data frames or queries and replaces them with your brand new, in your query. So by traversing all the nodes, Spark SQL sees or notices some queries that are cached. So all the blocks are on block managers, on executors. So he replaces it with something that will get executed faster. And then we've got logical optimizer. Logical optimizer makes your logical plan, analyzed logical plan, optimized, okay, whatever it means. And then we've got planner that takes this optimized logical plan and generates at least, and now in Spark SQL, exactly one physical plan, okay? There is a room for improvement because this API offers you a way to generate thousands of potentially fine physical plans, but now it only generates one. Okay, and this one physical plan is optimized by physical optimizer, by another set of rules. This is where whole stage code generation kicks in and generates code for you. So if you are looking at Spark plan alone or itself, you won't see this star in this tree output. While if you look at executed plan, you will see this star and all the subqueries reused and exchanges. Okay, and eventually you do RDD generation and you leave Spark SQL space. Okay, and this space too. So we've got 5-minute break, right? Yeah. Okay, 5-minute break.